Go to 5.5 in your notes. We're not. Today's Thursday. Test is Monday.
Yeah, but we're not doing it.
Yeah, we are. We only have a little tiny bit left of 5.5, and the portion that we do it'll work out of the packet. I don't know what page it says because mine doesn't have the page in the others.
I think it's 306.
Yep. Page 306. Oh, Max. Perfect person to start. On his phone. Okay, Max. What I need you to do is come up here and put a red dot on any location that has a slope of 0. You're not Max. I got Max head. Oh, wait. None of this is from yesterday. And now it's working. Perfect. That's it. I don't know, let's see if we can get it to actually go to red. There we go. Okay, when you are drawing derivatives, here's the number one mistake people make. Elijah, if I give you a graph of x cubed, what would its derivative look like? I bet you kind of know because you sort of know the derivative of x cubed. Yeah, yep. So the main mistake people make is that they kind of know what derivatives look like of regular polynomials. If I give you a graph that looks like a cubic, most people in their mind kind of already know that the derivative will look like a parabola. The problem with that method is that you don't know it's cubic. You're not going to be given the equation. A cubic function is going to look like any odd function. So you don't actually know if it's x to the 5th or x to the 7th. All odd functions look similar. So if you're just given a picture, you can't go by what you think the equation is. I mean, you can certainly use that info to judge if you did it right, I guess. But for the most part, like a graph like this, it doesn't match any polynomial you know. So the way that we go about drawing derivatives is we start off with something we already know, which is where there's slopes of 0, because that is the only place that is super easy to find. And wherever you have a slope of 0, the height of the derivative is going to be 0. So if I'm going to draw the derivative, I'm going to draw the derivative on the x-axis wherever there's a slope of 0. And then from there, it's pretty much just guessing. Max, call somebody from a different table. What do you guess? What's your estimate of the slope right there? Just a numerical guess.
Well, I thought he was going to say
Definitely not. It's
Or
negative.
negative.
Okay, so -1 would be an okay guess, -2 would be fine, -3 would be fine. You don't have to know the actual number, we're just guessing. So you went with -1, we'll just go with that. Okay, good. Choose somebody from a different table. you say 83? Okay. 20, probably back there? 26? That's the actual one empty test.
Oh, 25.
25. Okay. What would be the height of the derivative when it has a slope of -1? When the original has a slope of -1? Nope. When our original has a slope of 0, the height is 0. When our original has a slope of -1, the height is good. So I'm going to draw my derivative with a height of -1 right there. I should have done red, sorry.
Is that on 8? -8 or
I don't know, I can't see. From the side, I can't tell. You just draw it directly below the point. Yeah. And since we're guessing, it doesn't really matter anyway. All right. Zach, who do you got next? Back table maybe? That person's gone.
That's
Oh.
Elijah.
Elijah. Kind of already called on you. Pick one of your table mates.
Oh, Jason.
I was literally about to say not Jason, but all right, Jason.
Jason?
Jason, there's already actually a point drawn there, I think. I don't think Max put that one up there. Yeah, you guys have it on your paper. So let's just use that point. What would you estimate the slope at that spot to be?
Like +2.
+2? I would even say a little bit bigger, but 2 would have been okay. So I would even say that's like 5 or so, because it's pretty straight up and down. 2 would not have been wrong. Okay, so who's going to help me answer the question? I thought that was pretty fair. You were heckling him while he was answering. Aiden, what would be the height of the derivative where the original has a slope of 5?
The height would be 5.
Good. So right above that, I will go to a height of 5. I want to erase the, there we go. Keep going,
Just pick someone else.
unless you want to keep going.
Let's keep Gus going.
Gus? Okay. Actually, there's a point right there. Let's go with that one. Was there other points that I missed? No, just those. Just kind of points at weird spots. What's the slope at that location right there?
-3.
Sure. So then my height would be drawn at -3. So all of these red points are the slopes of the original function, and these red points are going to be my derivative. And once we have enough of these points, I usually just pick a couple points around the slopes of zeros, and then I just make a smooth graph from those points. Okay, so this will be my last spot. Oh, you know what? I guess I could have had you do that one, Max. This one's the slope of 0 at the end, but it's sort of unofficial because it's at the end. But we can tell it was flattening. Okay, so there's another dot right there, Gus. Somebody over here.
27.
I don't know where we're at.
You didn't pick 27.
Slope there.
Like 2.
Okay, sounds good. Derivative would be at a height of 2. Drawing derivatives is extremely easy once you understand what you're trying to do. It always feels very complicated until you get the hang of it, and then you can do it for any function, no matter how terrible it looks. Okay, so I'm going to take all my red points and just kind of smooth make them together. Maybe I should have started with the original one, but that's not terribly far off from the slope of -1, so I'll just say it's like down there. So I'm just going to kind of draw, going through my points. And you absolutely are given plenty of margin of error for your graph. When I correct these, the main thing I look for is the slopes of 0, and then whether your lines in between are roughly correct. Like positive slopes, negative slopes, that's what I look for. So the main thing is the slopes of 0. And when you do these on the AP test, that's how they grade them as well. They look for things that have to be absolutely correct, which that's pretty much the only things. And then from there they estimate.
Wouldn't the first point technically be 0 as well?
Right here?
Yeah.
No, because this slope looks like it is roughly -2-ish.
Oh, it's just because that one's coming out, okay.
The end point over there was flattening, and so it had a slope of 0. Okay, do you want me to pick another graph and just have you guys try to draw it really quick?
Yeah.
Because I think there was one on the next page. No, not this page. Right there. So example 6, I guess 2 pages afterwards. It's not horribly different, but it's obviously a different graph. Just see if you can draw that derivative relatively quick. And then once you figure these out, they're like the easiest points there is. There definitely will be one of these on the test. And for the most part, everybody gets full points or no points. There's not really any in between.
Do the last one.
Are you making inside jokes over here?
We're not, he had a weird, you heard his weird.
His what?
I don't know why that happened, I didn't intend for that to happen. That's funny, it's in his. I had to laugh quietly.
Oh. It's okay, I had a professor once that had probably the most unique laugh I've ever heard. And it took a good half a year to get used to it. He would go from 0 to 100, and like his laugh would just be extremely loud right at the beginning, and then just kind of taper off. And it almost felt like a fake laugh, but it definitely wasn't. It was really strange. Like some people sometimes have really strange sneezes. I got 4 points of the slope of 0. Yeah, no, right here.
Hey, watch it back.
No, that's like,
Wait, what was fine? I'm so sorry.
Same ninja thing with the 400 feet.
my rough estimate of the derivative. Well, that's fine. That's okay. So like if yours is kind of more aggressive curving, that's fine. The main thing is if you are unsure about what it looks like, don't forget that you can just put even more points. Like you can just estimate like 100 different slopes if you really want to. I'm not gonna require you to, but like if you're very, I know some of you guys second guess yourself quite a few times in the test. Make a whole bunch of points. Okay, that is the rest of 5.5.
Yes.
So the homework that I gave you guys for 5.5, what we did right here was the entire front page. Because the front page, you were supposed to match up original functions to derivatives. And I felt like there was one question that was related at the bottom that was different. Maybe it was draw your own?
You just identify which case.
Oh, kind of the same thing, okay.
So, for 5.5, are we basically given a function and trying to draw the derivative off the function? in the
Correct.
Picture?
Yep,
Or is this a picture also gonna be on the test, and we have to draw from a picture and the function? Or is it just gonna be function? Cause we already got the,
you would do exactly what we just did today. You'll be given a picture and you draw a picture from that.
oh, will we ever just be given a function without a picture?
I don't know, it's just like.
But you wouldn't be asked to draw that derivative, you would be asked to find that derivative. Okay, optimization. Which, not at all. I know Kendra told me multiple times. It is nothing like related rates. It has absolutely nothing in common. That part is fine, that's true. Okay, we're gonna start off with a very basic one. And then we'll move to like more actual lifelike problems. Find two positive numbers such that the sum of the first and twice the second is 64, and whose product is a maximum. Optimization. This isn't even a top 10 weird sentence in
It
Kelly.
was just like the way I had to read it.
Okay, the word optimization means you are going to find a maximum or a minimum. It's one of those two. You're trying, whatever situation you have, you're trying to make it the biggest or the smallest, whatever it represents. This one, two numbers. And in one way or another, it will have to say maximum or minimum, even if it is inferred. The wording will let you know what's being asked. I want to say on the AP test, I don't think they would ever infer it. I think they would directly say maximum or minimum. Okay, so whatever we are asked to maximize or minimize is going to be our primary objective for the problem. So on this one, the product of two numbers. Trying to remember who went last.
It was Gus.
Gus went
I don't, did you pick
Gus
somebody?
went last.
Yeah, Audrey.
I go last.
Oh, no, you don't have to answer, unless you want to.
13.
Okay. Back there. Ignore, are you 13? Excellent. On the problems we've just been doing for the past week, how did we go about finding a maximum? First derivative test. We're gonna do the first derivative test on this info, which currently seems insane, but we'll get there. Okay, so your primary objective is what we're gonna be working with. Currently, not possible, or we don't want to. You will always be given a secondary piece of info to help you solve this. So on this problem, the only other information it said is that the sum of the first and twice the second, we're basically just saying x is the first number, y is the second. The sum of the first and twice the second is 64. Okay? The only thing we use that info for is to substitute a variable. That's where it is semi-like related rate. where we can substitute info. Which one do you wanna solve for, X or Y? I mean, I guess from my perspective, X is way easier to solve for, because then we don't have to cut it in half. So X is 64 minus 2Y. From that, we will automatically go over here and get rid of X. And it doesn't matter which one you substitute each time. You basically substitute the easiest way possible. Okay, so Ignore told me to take the derivative because he said do the first derivative test. Zach, what do we need from the first derivative test?
If the critical numbers equal 0 or undefined. First derivative.
When the first derivative is 0 or undefined. We want critical numbers. You were trying to say it correct. Okay, good. Zach, do you also feel like you have critical numbers down pretty good by now?
For the most part, yeah.
Oh, well, that was a worrisome answer. I was gonna let you choose another expert. Or do you wanna keep doing it?
I'm choosing one.
Okay? Whole point of the expert is you'd have it down pat. And that means by the test, you should have this down good. Who's gonna be our expert for the next 2 days?
10?
Oh, you're just going with number. Vincent.
Okay.
Vincent, do you remember how we find critical numbers?
When the first derivative is equal to 0 or undefined.
Excellent job. Okay, so now I need to find this derivative. So I want to find max prime. You don't have to know what this represents. Okay, so I think instead of doing product rule, I think I'm gonna multiply it out. Because that derivative will be very easy. So max prime would be 64 minus 4y. And Vincent told me to make this equal to 0 or undefined. 16? Okay, now, 16 is our only critical number, and that means we need to figure out if 16 is a max or a min. There is actually 2 ways to do this. I only taught you one so far. Baden, I believe you are in charge of second derivative info. Okay, so you were in charge of possible inflection points. Was it Jason, you were critical numbers, or excuse me, inflection points?
Yeah.
Okay, so you both kind of deal with the second derivative. Do you remember what the second derivative told us?
Curvature.
Okay. Every single maximum would have what kind of curvature?
No curvature.
Negative.
Oh, it's concave.
Because the maximum would be at the top. Every single minimum, positive curvature. I shouldn't say every single, that is kind of misleading. If you have a sharp point, there's no curvature. So there is an alternative method to figuring out max or min that's pretty much what they call it. Like, it doesn't have a real name. You can look at the curvature, and if your critical number has curvature, that will tell you if it's max or min. And sometimes that is much faster than making a table. So at this stage, our goal is to figure out if this is a max or min. And if you want to make a table, the number line table, make that. If you want to use an alternative method, we could find the second derivative. And on this one, the second derivative is -4. That means every single point has a negative concavity. So 16 would have a negative concavity. That would mean 16 is curving down. That would mean 16 is a relative max. Now, if you decided to do the number line, you would just find out that 16 has negative slopes before, I said that backwards, positive slopes before, negative slopes after, and that would make it a relative max. Both methods work. You guys are allowed to choose however you want. I just wanted to show you this alternative one because it sometimes is very fast. But the issue is it doesn't always work. Like if we didn't have any concavity, it doesn't, you can't use it. Okay, so we found out 16 gives us maximum product.
Can you explain why
Which part?
the -4 and the double prime?
Okay, so when I did the second derivative, I found out every single number on this function has a negative concavity. So the entire function is curving downwards, no matter what number you put in place of the variable. And if 16 is either a maximum or a minimum, a negative concavity would mean it has to curve down, so it's a max. Audrey, you were the last one to go.
No.
Ignore? Okay, who's gonna help me answer this final question? 3? I don't know which one you three. Oh, okay. Am I done with the problem? What do I need, what else do I need to do? What did it ask us to find? Okay, perfect, I'll just stop, that's perfect right there. Every one of these questions is gonna ask you to find something different. Sometimes you will be done right here. Sometimes you have to do more work. It's just what the question asks for. This question said find both positive numbers. We just found one. How do we find the second one? Perfect. The secondary equation will always be our method of finding the other answer. So x is 64 minus double y. So x is 64 minus double 16, which is 32. So this is optimization. Optimization is you're going to be asked to find a maximum or a minimum. To do that, you do the first derivative test. To be able to take the derivative much easier, you'll have another piece of information to substitute. Every problem has to be set up with that info. Otherwise, you can't do it. Okay? I think we get a 24? Oh, okay. Should we do the pasture adjacent to a river? Okay. I mean, it's clearly a real world application we'll be doing this summer. On my cabin land adjacent to a river, I will be buying some cattle. It would be kind of fun, actually. What did it say? A fence, a rectangular pasture, okay? Adjacent to the river means that there's not gonna be a side on that side. So the river is the fence. Even though cows can go in the river, so I don't know how that works. What? 100% they do.
What if it's deep and they just drown?
What do you, how do I know? You've never seen a cow in water?
No.
You guys ever leave the city? Come on.
How am I supposed to leave?
Even if you drive somewhere, you see cows on the side of the road, they always have ponds for
They
the
just
cows
don't cross
because they
the
like to
because they
swim
know
in
that
there.
the
Go
river.
on.
Have you ever seen a snow?
They can actually see the river.
Nick, your knee's been backwards.
Pasture must contain 180,000 square meters. What oh, it's just a rectangle. I thought this was gonna be more complicated.
I've
Okay.
seen cows. How do you get the?
I already forgot who win.
And horses. I knew that.
Who's gonna go? Debbie. Who's going? Oh, Ruth went? My bad. Still don't know your part. You guys look too alike. I know you do your hair different every day, but you guys constantly swap it, and so it confuses me. Huh? Well, you should look alike. I mean, it would make sense. What do I have to maximize or minimize?
just like yours. How much do you give these guys?
It will tell you.
Just know it's from about
Maximize the amount of grass each car can
That actually would make sense, but nowhere in there does it say that. What you're saying does make sense, but no. It tells us there's an exact amount of grass. There's gonna be a word that references bigger or smaller. It's not always going to be maximum or minimum. Oh, I didn't think I was gonna have to take a break on this one. Least what? Because you're cheap. I'm cheap. I always want to pay the least amount of money. Sure.
Sounds better.
I'm okay for being called cheap. If I'm buying fencing, I would like to buy as cheap as possible.
So it's a minimum?
Correct. A minimum amount of fencing. Doesn't matter what you call this. You can call the variables whatever you want. So we've got X and Y. Cullen. Somebody else, otherwise we're gonna run out of time.
I mean, I'll just go 5
Well, half your table has already gone because Max started off the day. 31. Are you 31, I'm assuming? Okay. How much fencing do we need according to this picture?
Is it at least amount?
Yes, we're trying to find the least amount, but that's not. I need to write an equation that represents the amount of fencing I need to buy according to this picture. Perfect, the perimeter, 2x plus y. And this is gonna be a minimum. No, that's area. So the amount of fencing you would actually buy would be perimeter, because you wanna find out how many feet of fencing. The secondary piece of info is area. The secondary piece of info is it tells us we have to have 180,000 square meters, because apparently that's how much grass the cattle need. So X times Y is 180,000. Dylan? Somebody needs to guide me from here. I've got some equations and info written up here, but somebody needs to tell me what I'm trying to do. Because this is where people get lost.
21.
That was a lot of thought. Oh, so you're trying to substitute X or Y out in the original primary function, because this is what we need to take the derivative of. Okay, on this one, it most definitely doesn't matter which letter you pick, because they're the same. Okay, over here, I'm gonna have 2 times 180,000, so 360,000 over Y plus Y. Your derivative can be done 2 ways. We could come and denominator that to make quotient rule, or we can take the derivative of each individual term. I don't know if you guys have a preference, but either way, we're taking the derivative. So I think I'm gonna leave them as separate, and then we'll see how it works out. This is 360,000 y to the negative 1. So my derivative would be negative 360,000 y to the negative 2. And then my derivative of y would be, oh, I don't know if I need to mention this. This is different from related rates, because we are not actually we're treating whatever letter you use as the main variable. So you don't ever have to do chain rule, like we don't have to write dy dx. So when we're doing optimization, whatever letter you're using is the main focus. So you don't have to worry about extra things. So this derivative is just 1. And then I need to make that,
Oh, wait, yeah. Make it 0. Wait.
or,
Or undefined.
good. I need to figure out if this is equal to 0 or undefined. I automatically know right away there's an undefined of 0. But, well, we'll get there. So, I'll probably write this as a fraction and then common denominator. So this is gonna have to be y squared over y squared. So y squared minus 360,000 over y squared. I needed to put these two terms together. So I common denominated them. Y to the negative 2 is y squared on the bottom. So that I could put it together with this one, the common denominator. Because I'm only looking at three? You could have done it up there as well. This is before I did the derivative. So that derivative is just
Yeah,
one.
it's 1.
But I'm trying to make it equal to 0.
Because you have plus 1.
As soon as you really say it.
I don't know how to say
Oh,
differently.
there, he's gonna explain.
Well, I didn't see that the one was under it.
Okay.
Multiplied it by one.
I got it.
Oh my God, you covered it with one.
Well, yeah, I'm not gonna.
Because really it's y to the negative 2.
Because that's what I changed it into. This is one.
No, that's the end derivative, but then you come denominator.
I only have so much space.
Still keep
Okay,
I just did it.
we have an undefined value of 0. Why is that value of 0 kind of worthless for this problem? You're not gonna have a length of 0 for a fencing. So, there isn't technically, domain restrictions, but there are gonna be like common sense domain restrictions for each problem. So like for the fencing, it doesn't directly say you have to have positive answers, but that's understood. So 0 is a critical number, but it's not one we'll use because it's just worthless. So, my other critical number is going to be when the numerator equals 0. I want to say it's 600. Is the square root of 3 or 600? Okay, so we get plus and minus 600. Negative 600 we won't use. So positive 600 is our critical number that we're going to check out. There's 3 critical numbers, only one of them is worth anything to us. And we need to figure out if that critical number is a max or a min. We want it to be a min. I will just tell you right now, if you do these problems correct, you're never gonna get a number that's the opposite what you're looking for. But you still have to check, like you have to prove it. So I need to prove that this critical number is a minimum value. And I need to do that with either a number line or the second derivative. If I'm being honest, I don't want to do this second derivative because it's kind of ugly. And it would be a lot of work. So it's quicker for me just to do a number line. Put 600 and then test the slopes before and after. So if I test the slope of 100, 100 squared, 10,000, minus 360,000 is negative over positive, so this is a negative slope, which would be down. And then I'll test a number bigger than 600, like 10,000. 1,000. I guess 10,000 would technically work. But, 1,000 squared would be 1,000,000. It would be 6 zeros, I believe. And then 1,000,000 minus 360,000 would be positive. Divided by 1,000 squared would be positive. So my slope table tells me it's a relative minimum. So I just found out that the the y is equal to 600 meters. And I have to figure out what x would be. X is 180,000 divided by 600, yeah, 300. I'll write it over here so you don't miss it. Okay, what can make these more complicated is the initial setup of the problem. So the main thing that can make these more complicated is your equation that needs to be minimized or maximized. That's really the only thing that can make it more complicated for you trying to figure out the drawing. But a lot of these problems will have a drawing. So I fully get that you guys have a ton of work to get ready for Monday. So in terms of your homework, I am okay if you don't finish the homework. What I want you to do is make sure to try every type of question. So between 5.5 and 5.6, they are all very time intensive. And things are going on. We got the Super Bowl, there's all sorts of stuff going on. That is this weekend. So there's all sorts of things. Luckily, there's a snowstorm Saturday, so you'll be home. And that way you can get all your calc done. But I am okay if you don't finish either assignment fully. Turn in what you have by Sunday. But make sure you try every type. But we're going to do some of these together tomorrow.
0, 1.